Alrighty then, my game dev gangster, let us now create the jumping effect. And in order to do that, we need to go here above, and right above awake and below the player animation, we need a few variables. The first one is going to be a private layer mask, and I'm going to call ground, not Gorund, it's ground layer, because, well, we need it. We will see why. Don't worry about that. Just kidding, but we are going to use raycasting, and we are going to filter out layers that we can detect collision with, so that's why we're going to use the ground layer. We're also going to use here a serialized field, private transform, and this one is going to be our ground check position, and we will see what this is. Basically, we are going to place an empty game object below the feet of the player. From there, we are going to cast a ray and check for the ground. And we're also going to get a reference to our box collider 2D, which I'm going to call box call 2D. Now over here inside of the awake is where the action is going to happen. So I'm going to say box call 2D is equal to get the component box collider 2D that we already, have attached on the player. And right here below everything, so below the player animation, we are going to create a function that is going to detect if we are on the ground. But before that, I am going to go quickly back here inside of our editor, because we need to attach, we need to click here and we need to create an empty game object, and this one is going to be our ground check position. There you go. And let me zoom in on it. So here it is. I'm going to move it a little bit down. Let me just maybe tag it like this with this little circle here so that we know where it is. Something like this, right on the feet of the player. And this is where the ground check position is going to be. So I am going to attach it over here. Now, when it comes to the ground layer, as I said, we are going to check if we are colliding with game objects who are on a specific layer. And what do I mean by the layer? Well, with the layer, I mean this over here. You see on top, when you select a game object in the inspector, you have a tag. And then right next to it, you have the layer. And over here, you have the default layers, which are created every single time you create a project. But over here, we can click on add layer and we can create new ones. And I'm going to create the ground layer. And I'm going to attach that or make the ground game object be on that layer. There you go. I'm also going to change this to 0, and there you go. Or actually ground, simply rename it to ground instead of 1. But the point here is to set that ground on this ground layer, which means over here in the player now, for the ground layer, I can select over here the ground. So that means now when we use this ground layer, it is going to detect if we have, collided with game objects who are on that layer. If this is not clear, something is not clear when it comes to this, make sure that you ask in the comment down below. Also, make sure that you like the video and subscribe to the channel. Did you know that you don't have to wait every single day for me to publish a video to finish this tutorial series? You can access all the videos right away in my Game Development Academy. Click the link down below. You will access this tutorial series, all future ones that I publish, plus 80 other courses where you can learn game development from. Click the link down below and check it out. So over here, I am going to create a function that returns a boolean, not a beak. It returns a boolean is grounded. So is grounded. And don't panic. This is not your parents grounding you for a week or whatever. This is just a function that will detect if we are on the ground. So what we are going to do is here we're going to say return, because we need to return a boolean. And for that, we're going to use physics 2D, and we're going to raycast. So raycast, and I'm going to raycast. And over here, you see we need to provide a few parameters. Of course, there are numerous parameters that we can pass in this function. One of this is the origin. So basically from where we are going to throw that ray. So we're going to throw it from the ground check position, that position. And now the direction where we want it to go. So the direction is down. Now the distance, we are going to say 0.1, and last but not least, we are going to pass here the ground layer. There you go. And this is going to return and tell us if we are on the ground or if we are not on the ground. Now for us to better see this, or basically how we're going to use it, we're going to use it like this. We're going to go here and create a void handle jumping function that is going to handle the jumping. And over here, we're going to check if we input, so if input get button down. So if we press the button down, and we're going to pass here jump. But of course, over here that we can, create a public static string jump button. And over here, I'm going to say jump, and there you go. And simply over here, we can call it like this, tag manager dot jump button. So if we press the jump button, and if you don't know what this is, this get button down and passing here jump as a string, basically this will return true during the frame the user press down the virtual button identified by button name. The virtual button basically meaning this button, if we are on mobile, or basically if we're a computer, that will be space. If we are on consoles, that is X, and so on and so forth. So this is a universal way to call the common button that is used as a jump button on different consoles. So if we press that jump button, then we're going to say if is grounded. So if we press the button and we are on the ground, then we're going to say my body velocity is equal to new vector 2. And this time, because again, we are also going to preserve the velocity x, same as how here we preserved the velocity y. So we're going to say my body velocity x, and for the y is going to be jump force, and there you go. Now this right here is going to be called inside of the update. Now I know, teacher, you said that we cannot use any code that tackles the velocity rigid body. Don't cry, okay? Do not cry. As I said, this is the general rule, but sometimes there are exceptions to the rule. The reason why I have added this in the update function is because update function is called every frame in a second. So if we have 60 frames, this will be called 60 times, whereas fixed update is not called every frame. It's called, let's say, every 4th frame. Now it can happen that we press a button on frame 2, but fixed update is not called on frame 2, it's called on frame 4, which means our button press will not be registered. So the button press, again, I'm repeating that, button press will not be registered and we will not jump. Simple. What else can I say? If I go now inside of the editor, we will be able to jump, hopefully. So let's go and try it out. So if I hit the play button, if I jump, there we go, we have jumped, and voila, look at that, we have jumped. But I'm going to show you one thing. First things first, I'm going to show you how this ray functions. And basically it functions like this. It throws a ray. An array is a line from the origin position. So if I go over here, what we are doing, we are ray casting. So we are ray casting from this position, meaning from this position, let's assume this position is here, we are throwing a ray in the down direction, so going down, and this right here is the length of that array, not array, but simply ray. So this is the length. And we're checking to collide or for collision with game objects who are on the ground layer. So we are checking to collide with the game objects who are on the ground layer. We know that the ground is on the ground layer because we said it a moment ago. And basically that's it. And in order for me to show you that this actually is the case, I am going to use here debug.drawArray. And over here, we're going to say ground check position. So that is the origin, that position. And next we need to say the direction, which is going to be vector 2 down. And we're going to multiply that with 0.1f. And next over here, we're going to say color red. So over here, color red, and voila, there you go. Now the draw ray doesn't take parameters same as the raycast. Instead, it takes the position from where we're going to draw that ray. This is the direction and the length. Because over here, the direction is one parameter, the length is another, but we can multiply the length with the direction and it will give us how, long that ray is going to be. And color red is going to display or draw it basically. But I need to call it over here in front of this or before the if statement, because if we call it like this, it is going to wait for our input. So before we press the button down, it is not going to call this over here to test it out. So if I go back now inside of the console, actually inside of my editor, and hit the play button, we are going to notice if I go here and if I take the ground check, I am going to untag it, so none, and voila, now we see that ray. Look at that, you see this red line, this is that ray. So this is how we are detecting. So this line is touching the ground basically, and it detects if we are colliding with the game object who is on the ground layer. If it returns true, which this case is true, then we can jump. But I'm pressing again now and I cannot jump. You see, pressing again now and I cannot jump. I cannot jump. We are also not, displaying the jump animation. Don't worry about that. We will cover all of it in a moment, because I need to explain everything so that you understand. This way is, let's say a good way to do it. And I say, let's say, because if I do this, And I'm going to take this, I'm going to move it here, and voila. Now, what if I jump over here on this ground? Will I be able to, jump from this ground? Yes, I am, but there is one issue. What if I get to the edge, which is over here? Look at that. And if I take the ground check position, and again, if I remove this, look at this. Now the ray is casting over here. He is not detecting that we are on the ground. We are visually on the ground. I'm pressing to jump, but I cannot jump. Now, the reason why I cannot jump is because of this. Look at that. This ray is over here. It's not touching the ground. The ground is over here and the ray is over here, so it has a gap. And this is why this way is not that good to simply use draw ray in order to detect if we're on the ground or if we're not on the ground. Of course, you can potentially have 3 rays, and let me just remove this from here. You can potentially have 3 rays. You can, have 3 of these ground check positions. So maybe you can have one here, and then you can have another one here, and stuff like that. So that can also work. So you can do it like that, but there is a better way how to do it. And basically, what we need to do, that is the reason why I've used this box collider. So what I'm going to do here, instead of using this to return the raycast of the ray, instead I am going to say here return, and I'm going to say physics box cast, and this is going to cast a box instead of a ray. And ray is simply like this, and a box is like this. So there we go. And we're going to use our box collider. So I'm going to say box call 2D. So box call 2D dot bounds dot center. And this right here is the center of the bounding box, because when we use this, this is the origin. So from where we are going to draw the box. Next, we are going to draw the size of that box. So we're going to say box collider bounds.size, and this is the size of it. So the total size of the box, this is always twice as large as the extents. And next we are going to say the angle, basically 0 angle. So we are not going to draw this box like this. Instead, we're going to draw it like this. So going down, not going here in this direction. Next, we are going to say where. So the direction where it is going, so it's going to be vector 2 down. Next, we also need to say the distance, which again is going to be 0.1, so the length of that box. And last but not least, we're going to detect if we are colliding with the ground layer or not. Now, there is no way that we can use debug.drawBox, and it is a little bit complicated to draw it with the ray, so I'm going to leave it out. It's not important, but what it is, or what's important here, is that that ray is going to look like, or look something like this. So if I jump over here now, and we're also going to fix this jumping, don't worry about that because he's jumping too much. Basically, that ray looks something like this now. So like this, there you go. So it looks like this because it's now a box, and it goes from here because that's the center of the collider, and it goes down, and there you go. And this is the size of that collider, and so on and so forth. So if I try to jump now, even though I am at the edge, you can see we have jumped. Look at that. There you go. Now, when it comes to jumping, because the player is jumping a little bit weird, look at that. He's jumping a little bit weird. So what we are going to do is we're going to take the player, and over here for his rigid body, I'm going to set the mass at 2 and gravity scale at 2. And let's try to jump now. So now he jumps a little bit better. Look at that. So now he jumps a lot better. Not a little bit, but a lot better. So again, make sure that you set the mass to 2 and the gravity scale to 2 for the player. And this is how you play with different things when it comes to the effects that you want to achieve. So you can also play with the rigid body. Mass is basically how heavy the object is. Gravity scale is how the gravity is affecting that object, and so on and so forth. So going back over here, so this right here we have explained. So physics box cast, it is going to cast a box from this position, which is basically the center, which is, somewhere around here. If this is the player and this is his collider, the center is somewhere around here. So from there, it is going to cast that box. Now, the size of it is going to be the size of the whole box, which means this is the whole size of that box. And this is the angle, which means we don't want to rotate the box. It's going to go down, and the direction is down. and this is the length, which means if this is the player, and I've explained that, so it's somewhere around here, that box is going to be casted, and it is going to check if we collide with game objects who are on the ground layer. And that's all there is to it. So the last step is to animate the jumping, because so far we didn't do that, and simply with a simple line of code we are going to say play jump animation, and over here we need to pass is grounded, but we need to pass it with an exclamation mark. So notice here we're passing it with the exclamation mark. What does this mean? Why am I passing it? Well, because here, this is grounded, and this can be removed because I just use it to draw the ray and show you that. So the is grounded will return true if we are on the ground. So if this right here returns true and we actually are colliding with the game object who is on the ground layer, then this will return true, and then this will return true. We are not going to play the animation when we are on the ground. Instead, we're going to play the animation when we are off the ground. So when we jump, and when we jump, we are not going to detect that we are on the ground layer anymore, or basically colliding with the ground. Instead, it is going to be false, and this is going to make it the opposite, which basically means, you know, the opposite of false is true, and then this animation is going to be played because, as I already said, we are going to play the jump animation. Notice here when I click on the transition, the jump animation is going to be played when the jump parameter is true. So I am using the exclamation mark to make what's after the opposite, which means when we jump, it will return false because we are not on the ground anymore, but the exclamation mark will make it the opposite, which is true. So if I hit the play button, as soon as he starts to fall down, you will see he played the jump animation. Look at that. We jumpy, 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 jumpy player, jumpy player, blah, blah. I'm just kidding. Anyways, if you like my jokes, subscribe and hit the like button. Anyways, you see that now we are playing the, jump animation, and as soon as we land, we are going to either transition to the walk animation or we're going to transition to the idle animation. So if I'm not moving, and this is all because of these transitions. So we're going to go from jump to idle if the walk equals to 0 and jump is false, and you get the point, yada, yada, yada. We're going to go from jump back to walk if the walk is greater than 0, or actually greater than 1, and jump is false. There you go. Now, if something is not clear when it comes to this lecture, make sure that you ask in the comments down below, and I will see you guys. Before I actually see you guys in the next video, I am quickly going to create over here a folder for prefabs, and we're of course going to, drag and drop the player prefab over here. So player prefab. Because now we're going to start creating our enemies and yada, yada, yada. So simply drag and drop the player, and there you go. So we have created our player. Again, if something is not clear when it comes to this lecture, how we utilize the box cast and how we utilize the ray cast and all of the good stuff, just make sure that you ask down below, and I will see you guys in the next video.